Hello, viewers. Welcome to the lecture series of Numbers as System. This is your tutor Keshav Agarwal, and this is the very first lecture for the SSC examination preparation. And let us first have a look over the contents of this chapter. So, first of all, we are going to start with classification of numbers. Next, we will move on to divisibility test, and next we have unit digit, number of zeros, remainder theorem, number of factors, and at last we have series, AP, GP, and harmonic progression, arithmetic progression, geometric progression, and harmonic progression. So let's get started. So, what are numbers? So, in everyday life, we come across numbers. Whenever we are talking about quantity, suppose 2 apples, 3 apples, we always use numbers. So, a numbers is a group denoted by digits, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the most basic digits we have in mathematics, and rest all of the numbers that we see or speak or study are made using these numbers only. So numbers are basically classified as real numbers and complex numbers. So real numbers are all the numbers from minus infinity to infinity. Whatever number you speak, you see around yourself, everything is a real number. But there are some more numbers in mathematics which are complex numbers, but we usually don't always study the complex numbers here. Right now we are going to confine ourselves up to real numbers only. So next, what are various types of numbers? So first of all, we have natural numbers. So numbers that we use for counting numbers are called natural numbers. So natural numbers, what are natural numbers? 1, 2, 3, 4, 5 to infinity. So if anyone asks you, so what are natural numbers? You can simply just say the number starting from 1 and goes till infinity is what we call as natural numbers. Next, what do we have is whole numbers. The set of all counting numbers including 0. So that is whole numbers. That means whole numbers are nothing but 0 included with natural numbers. So whole numbers are 0, 1, 2, 3, 4 and till infinity. So next we have integers. So what is an integer? Integer are combination, a set with natural numbers and negative natural numbers and a whole number, that is 0. So if I have to write it for you, then it will be 0, 1, 2, 3 and till infinity, and -1, -2 and till infinity. This is what is a integers, a set of integers. So if I ask you what are all set of positive integers, that means I am asking you to include only positive integers. That means you have to exclude negative integers as well as 0. So then your answer should be 1, 2, 3, 4, 5, 6, so on. Or in simple terms, I can say that it is nothing but natural numbers only. Okay. And if I ask you about negative integers, then your answer should be -1, -2, -3, -4, and it goes on till minus infinity. So negative integers are nothing but negative of natural number, or I can say natural numbers with a minus sign. Okay. So question may come up and where they are talking about these particular sets, positive integers, negative integers. So then in that case, you must clearly know that 0 is not a part of this set and negative integer is not a part of this set. So next, we have set of all non-negative integers. So in this case, I am asking you to exclude all the negative integers and okay, yeah. So in this case, I am asking you to exclude all the negative integers. So the set you will have is 0, 1, 2, 3, 4 and so on. And this is nothing but whole numbers. Okay. And if I am asking you the set of all non-positive integers, In that case, you will have 0, -1, -2, -3, and so on till -infinity. Because when I'm talking about non-positive integers, that means you have to exclude the positive ones, but you have to include 0 in the set. Okay, so these are some basic terminology or basic information about the numbers which you must know, so that when we are solving the questions, you must clearly know that what kind of number we are talking about. So what is the even number and the odd number? So number that is divisible by 2 is a even number. A number that is not divisible by 2 is a odd number. So that means if a number have 2 as a factor, or if, for example, 2, 4, 6, 8, 10, 12, these are all examples of even numbers. And if I talk about odd numbers, then you have 4, 5, 7, and so on. So what are prime numbers? Prime numbers which has exactly two different factors. So you have to clearly focus on this thing. It should have exactly two different factors. One should be 1 and another should be itself. So let me just repeat myself. What are prime numbers? A number, suppose any number given to us, is said to be prime if it has only two factors. One of them should be 1 and another factor should be itself. For example, if I say 5, so how many factors do 5 have? One is 1 and another is 5. So 1 and itself. So it's a prime number. So if I ask you what is the lowest prime number, so just think. So number starts from 1, 1, 2, 3, 4, 5, 6 and goes till infinity. So 1 we don't include in prime numbers because 1 is the only factor. We don't have two different factors here. So what about 2? So 2 has factor 1 and 2 itself. So it is a prime number. And it's not just a prime number, it's the lowest prime number. And one more interesting fact about 2 is it's the only even prime number. Because if you check any other number, there will be more factors to it. Even number, if you check even numbers, there is going to be more than 2 factors to it. Okay. And what are first 25 prime numbers between 1 and 100? They are 2, 3, 5, 11, 13, 17, 19, and so on. So what are composite numbers? Composite numbers are very simple. Numbers which are not prime are called composite number. And 4 is the lowest composite numbers. Any other example for composite number? We have 6, we have 8, we have 9, we have 10. So all these are examples of composite numbers. So what is a coprime? Or we can say a relatively prime number. So two numbers are said to be relatively prime if their HCF is 1. So for example, 4 and 9, their highest common factor is 1. 15 and 22, their highest common factor is 1. So these are some examples of relatively prime numbers. To check relatively prime number, we must have two numbers and then we check with respect to each other whether they are prime, relatively prime or not. Next we have is twin prime number. So two prime number are which have difference 2. Two prime numbers having difference 2 is said to be twin prime numbers. For example, 3, 5, 11, 13, 17, 19. These are all examples of twin prime numbers. So till now we have studied about natural numbers, whole numbers and integers. Now we are going to study a very different and interesting class of numbers, that is rational numbers. So what is a rational number? Numbers which can be expressed in the form of P upon Q. Okay, and where P and Q are integers. So clearly try to memorize the definition that a number which can be expressed in the form of P upon Q is a rational number where P and Q are integers and Q is not equal to 0. Such numbers are called rational numbers. Let me give you a quick example to you. 1 upon 8. So 1 is an integer, 8 is an integer. So that means the number 1 upon 8 is going to be a rational number. Correct? Next, minus 8 upon 11. Minus 8 is an integer, 11 is an integer. So it is going to be a integer. Is 0 an integer? So is 0 a rational number? Let's see. Is 0 a rational number? 0 will be a rational number if it is written in the form of P upon Q. But here I am unable to see any Q. But let's see, just my friend. We have 0 upon 1. If I can write 0 as 0 upon 1. So 0 is an integer. Okay. And 1 is also a integer. So in that case, 0 is also a rational number. Okay. And what about 6? Same way, 6 can also be written as 6 upon 1. Correct? 6 upon 1. So it is also a rational number. What about this mixed fraction number? So this thing can be written as 5, 15 plus 2 upon 3. That comes out to be 17 upon 3, which is again 17 is an integer, 3 is an integer. So 17 upon 3 is going to be a rational number. So next here we have is irrational numbers. So what are irrational numbers? In simple terms, I can just say the number which is not rational is a irrational number. But let's see some more points which makes a number a rational number. So first of all, it should be non-terminating. Okay. And secondly, it should be non-repeating. So what do I mean by non-terminating and non-repeating numbers? Let us see. So if I talk about 1 upon 3, okay, so it is equal to 0.3333 dot 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 dot. So here 1 upon 3 is non-terminating, but it is repeating itself, because if you see after 0, when you see decimal places, it is repeating itself. 3 is repeating again and again. 3 3 3 3 3 3. That means it is not satisfying the condition for irrational number. So 1 upon 3 is going to fall in rational numbers, because one may say 1 is a integer, 3 is a integer, but the number that comes out to be is non-terminating. So how come that number is a rational but not irrational? So the simple explanation is 1 upon 3 is definitely equal to 0.333, but it is non-terminating, correct, but it is repeating itself. So it is going to be a rational number. If I talk about pi is something like 3.14, something like, it goes on and on. And very interesting thing about pi is it never repeats itself and it never terminates. The decimal values goes on and on and on. Many scientists have spent their lifetime calculating the value of pi, tried reaching the end of pi. Many supercomputers have tried to do it, but they could not. There is no end to it. If you go on dividing, it will keep coming and going on and on. So root 2, root 3, root 5, root 7, 0.23176473 dot dot dot, whatever number you want to put here. So it is an example of irrational number. So moving ahead, we are going to see couple of divisibility tests, so that when a number is provided to us, we should be easily able to identify whether that given number is divisible by 2, 4, 6, 18, and we are going to see divisibility test for a lot of numbers. So let us start with 2, 4, 6, 18, 2, 4, 8, 16. Okay. So first of all, how do you know if a number is divisible by 2 or not? So if the last digit of a number is divisible by 2, then the number will be divisible by 2. If last two digit is divisible by 4, then the number is said to be divisible by 4. If last 3 digits is divisible by 8, then the number is said to be divisible by 8. If the last 4 digit is divisible by 16, then the number is said to be divisible by 16. And if the last 5 digits is divisible by 32, then the number is said to be divisible by 32. Okay. So similarly, we have for 3, 9, 27 and 81. If the sum of digits is divisible by 3, the number is going to be divisible by 3. If the sum of digits is divisible by 9, then the number is going to be divisible by 9. If sum of digits is divisible by 27, then the number is going to be divisible by 27. If the sum of digits is divisible by 81, then the number is going to be divisible by 81. Okay. Now, for 5, 25, 125 and 625. So if last digit is divisible by 5, then the number is going to be divisible by 5. If last 2 digit is divisible by 25, then the given number is going to be divisible by 25. And similarly, if the last 3 digits is divisible by 125, then the given number is going to be divisible by 125. If the last 4 digits is divisible by 625, then the number is going to be divisible by 625. Okay. So what about 6? How do you know if a number is divisible by 6 or not? So to check that, we have to check that a number is divisible by 2 and 3. If we can make sure that a given number is divisible by 2 as well as 3, in that case, I will say that a number is divisible by 6. Okay. So how do you check for 7? Let us see an example to understand that. So 7, let us consider an example 658. So how do you know if 658 divisible by 7? So a very easy method to know that is you just take 658 and divide it by 7. If the remainder comes out to be 0, then you can say that 658 divisible by 7. But is that method feasible for you? Can you afford that amount of time to spend on a very simple and small question? No. So let us see a quick and very fast way to see that. So unit digit of this number is multiplied by 2. First of all, you have to identify the unit digit in the given number. So here unit digit is 8. Okay. And now multiply this unit digit by 2. So the answer you will get is 16. So next what you have to do is subtract the solution you got here 16 by the remaining digits. So 65 was the remaining digit. So subtract 65 with 16. So you will get 49. And if the number now obtained in the step 2 is divisible by 7, in that case we will say the number originally that was given to us is divisible by 7. Since 49 is divisible by 7 because 7 square is 49. So 658 will be divisible by 7. Okay. So what about 11? A number is divisible by 11 if the difference between the sum of digits at odd places and the sum of digits at even places is multiple of 11. Let us see with the help of an example. So suppose we have a number in which digit at even places are 7482 and digits at odd places are 5952. So what you have to do is just take the sum of even place digit, take the sum of odd place digit, subtract them, and the number should be divisible by 11. So 59 plus 5 plus this, we have 21. And some of these we have 21, which turns out to be 0. And now check that if 0 is divisible by 11 or not. So yes, 0 is divisible by 11. So number that is found using this digit is divisible by 11. Okay. So we have a very special rule for divisibility by 7, 11 and 13. Let us see. So for example, we have 380247. So what you have to do is, first of all, divide this number in the pair of 3 digits. So 380 and 247. These are 2 pairs. Okay. And now what you have to do is make the difference. Subtract them, and the answer we got is 133. In the next step, now check if the difference is divisible by 7, 11, 13. If it is divisible by 7, then it will be the original number will be divisible by 7. Since 133 is divisible by 7, therefore the number original that was given to us is divisible by 7. And the number 133 is not divisible by 11. So the original number is not going to be divisible by 11. Same goes for 13 as well. Okay. So now we are going to see how to identify the unit digit. So a large number will be given to you, like 133 to the power 1000. So how do you know the unit digit in that number? So one way is to just go on solving the number. Okay. So but that's not feasible at all. So how do we do it? Let's see. So when unit digit is 0156, so this is the number 120 to the power 41. Okay. So in this number, in 120, unit place is 0. Okay. So what we are going to do is, we are going to see when such number is given to us which have unit digit 0 and some power is taken for that, what will be unit digit at last after solving all the powers. Okay. So if you do that, unit digit is same as to unit digit place. There is no effect of the power in this case. So whenever you have unit digit place 0156 in the number inside this bracket, unit digit inside these bracket is 156. If that is the case, then whatever power may be given to you, at the end, after solving all the powers, the unit digit place is going to be nothing but itself. There is no change in the number. Okay. So power will that unit digit will remain same. If it is 0, you will get 0. If it is 1, after solving all the powers, you will have 1. If it is 5, then you will have 5. It is 6, then you will have 6. Okay. So you just have to remember this table that is in front of you. Okay. So one example, very simple example. So unit digit is unit digit of 120 to the power 41. So what you have to do is, first of all, identify the unit digit inside the bracket. So it is 120. So what is the unit digit of 120? That is 0. And we just saw, if the unit digit with this number is 0, that case, after solving all the powers, the final solution will also have unit digit as 0. So without doing any sort of calculation, we can just say that by just looking at a number, that the unit digit in this case is going to be 0. Okay. Same goes for this. You don't have to do anything. 121 is here. So 1 is a unit place, and we know that when 1 is a unit place, after solving all the powers, 1 is going to be the final answer. Okay. So next, what do we have? We have 4, 2, 3, 4, 7, 8 and 9. So for example, 132 to the power 31, 23 to the power 47. These are some examples we are going to solve. Okay. So what we have to do is, first of all, any power given to you, you have to divide that power with 4. Okay. So after dividing the power with 4, what you will have? You will have a remainder that is either 0 or 1 or 2 or 3. So based on that remainder, you have to decide what is the unit place going to be. Let us see it more properly and deeply. So when the unit place digit is 2, for example, this case, when unit place is 2 here, so what we are going to do? In that case, after dividing the power with 4, if the remainder turns out to be 0, in that case, the unit digit is going to be 6. Okay. If after dividing the power with 1, unit digit turns out to be 1, remainder turns out to be 1, the unit digit is going to be 2. If the remainder turns out to be 2, the unit digit will be 4. If the remainder turns out to be 3, in that case, the the unit digit is going to be 8. Okay. Let us see an example. We have 132 to the power 37. So this example falls in the category we just saw. So what you have to do is just simply divide 37 by 4. So if you divide 37 by 4, the remainder you get is 1. So for 1 remainder, you had 2 to the power 1 and the unit digit will be 2. Okay. So what if the unit digit is 3? If the unit digit is 3, you again have to divide the power with 4 and see what is the remainder. If remainder is 0, then the unit digit is going to be 1. If the remainder is 1, the unit digit is going to be 3. If the remainder is 2, the unit digit is going to be 9. And if the remainder is 3, your unit digit is going to be 7. So let us see an example. So find the unit digit of 173 to the power 39. Since we have is 3. So what you have to do is divide 39 by 4. So when you do it, you have remainder 3. So in that case, we have 3 to the power 3, that is 27, and unit digit for 27 is 7. So your final answer is going to be nothing but 7. So what if we have unit digit 4? So the process will be same. You have to divide the power with 4 and the remainder, if the remainder is 0, in that case, the unit digit is going to be 6. If the remainder is 1, the unit digit is going to be 4. If the remainder is 2, the unit digit is going to be 6. And if the remainder is 3, the unit digit is going to be 4. Let us see an example. 134 to the power 122. Once you divide 122 by 4, the remainder is 2. And in that case, the remainder is going to be 2. And in that case, unit digit is going to be 6. So what if the unit digit is 7? So you have to just divide the power with 4. So if the remainder turns out to be 0, the unit digit is going to be 1. If the remainder turns out to be 1, the unit digit will be 7. For remainder 2, you will have unit digit 9. And for remainder 3, unit digit is going to be 3. Okay. Find the unit digit of 1067 to the power 57. So again, you have to divide 52 by 4 and remainder is 0. So in that case, the unit digit will be 1. Okay. So now this is the case when you have unit digit 8. So when the remainder is 0, the unit digit is going to be 6. When the remainder is 1, unit digit is going to be 8. When the remainder is 2, unit digit is going to be 4. And when the remainder is 3, the unit digit is going to be 2. This was the case for 8. Okay, when you have unit digit 8, this case will be used. So you have 198 to the power 70. So what you have to do is just divide 70 by 4 and you will get remainder 2. And once you have remainder 2, the unit digit is going to be 4. Okay. So what about unit place 9? So for 9, if the remainder is 0, unit digit will be 1. For 1, it will be 9. If the remainder is 2, you will get 1. If the remainder is 3, you will get 9. Okay. Find the unit digit in 139 to the power 11. So the power 11 is divided by 4. The remainder turns out to be 3. Okay, and 9 to the power 3 is equal to 9. So this is unit digit is going to be 9. So now moving ahead, we are going to count how many number of zeros are there in a given number. So if you have 10, 100, 1000, you always know that number of zeros are 1 in 10, 2 in 100, 3 in 1000. But what if I give you a very huge number, suppose 250 to the power 1000? How you count that? You need some easy and simple way. So that's what we are going to see. So observe that 10 can be written as 2 into 5. 100 can be written as 2 square into 5 square. And 1000 can be written as 2 cube into 5 cube. So if we can say that for n number of zeros at the end of the product, we need exactly n combination of 5 and 2. So for any given number, if you can make pairs of combination of 2 into 5, the power should be same. Like for 1000, it's 2 cube, 5 cube. If you can write any number with these format, it may be not be written exactly like this, but some part of it is written like this, 2 into 5 to the power something. In that case, the pair number of combination you have for 5 and 2 exactly will be the number of zeros in that given number. Okay, so here we have an example, 380. 380 can be written as 2 into 2 into 5 into 19. So here we can write 2 into 5 as power 1, 2 to the power 1 and 5 to the power 1. So if there was another 5 here also, then we could have written 2 square into 5 square. But since we have only one 5, then we can only use 1 2, and another 2 will just be lying like this only. So we have only one pair. Okay, so in that case we can say that factor only 1 0 exists at the end of 380. So this can be easily seen directly also. We don't need any sort of calculation here, but let's see ahead. What about this? In this case, how do you know number of zeros? One way is to just multiply this number, but is it feasible? The answer is no. Correct? So how do you do it? So what you have to do is, first of all, factor all these numbers, okay, into their simplest form. 2L could be written as 2 to 2 square into 3. 16 can be written as 2 to the power 4. 25 can be written as 5 square. 60 can be written as 2 square 3 into 5. Now, what you have to do is you have to combine all these factors and identify how many combination of 2 into 5 you can make. So here I can make in total 5 square. Here I can total make a combination. Okay, we have some more numbers remaining here. So for 22 to 5 we have 5 square into 3 square, and 37 is a prime number, so it not have any factors of 2 and 5. So now what we have to do is how many factors can we make? Okay, so now let us first count fives. We have 2 fives here. We have 2 fives, 3 fives, and 2 more fives. Total, we have 5 powers of 5. And if we can get 5 powers of 2 as well, then we will be done. So we have 2 powers, 4 powers here, 2 power here. Yes, we have 5 powers of 5. That means we have 2 to the power 5 into 5 to the power 5. This combination is present. Oh, sorry, this will be 5 here. So this combination is present in the number given to us. So in that case, we will have exactly 5 zeros. Okay. So number of zeros in the given number is going to be 5. Find the number of zeros at the end of 100 factorial. So what is a factorial? 100 factorial is equal to 100 into 99 into 98 into 97, and it goes on decreasing till 1. You need to count how many times 10 is a factor in the expansion of factorial. A 0 at the end of a number is created by multiplication of 10, which can be factored as 2 into 5. In case of 100 factorial, you will have a lot of numbers being multiplied together, and some of them will have factor 2 and 5. Since 2 is more abundant than 5 among the 100 natural numbers, it's number of 5s that we need to count. What we are trying to say here is, among 100 factorials, among that 100 numbers, 2 will occur a lot of times. So instead of counting 2, what we are going to do is we are going to play smart here. What we are going to do is identify how many 5s are there. Because in the last question also, what I did not count 2 first. I counted number of 5s first. Because after counting 5, I tried to find out 2s. So here we are also going to identify how many 5s are there. And number of 5s, if we have 10, then definitely we are going to have number of 2s 10 also. So let's see how many 5s are there. To find the multiples of 5 in the number of 1 to 100, we can use the following formula. Number of multiples of 5 is equal to floor of 100 upon 5, that is 20. So we have 20 numbers among 100 natural number that has factor 5. However, some of these numbers have multiple factors of 5, like 25, 50, 75, which contribute additional zeros. That means if I say 5, it has only one 5. But if I say 20, it has also have one 5. But what about 25? What about 50? What about 75? It has more than one 5. So we have to take that into account as well. So to account for these additional factors, you can repeat the process for multiples of 25. Okay. So number of multiples of 25 will be floor of 100 upon 25, that is 4. So 4 extra factors you will have. So now you need to add these to the count, 20 from the first step and 4 from the second step. You have 24. So there are 24 multiples of 5, or 25 among the first 100 natural numbers, which contribute to the trailing zeros in 100. Therefore, 100 factorial has 24 trailing zeros. What do I mean by trailing zero? 24 and 100 factorial, they are going to be 24 zeros at the end. So what is the remainder theorem? So suppose if you divide any number, so we have 37. So 37, when it is divided by 5, so what you do here is, correct? Now you stopped here. Okay. So here, this 5, we call this 5 as divisor. Okay. This 7 as quotient. Okay. This 2 as remainder. And this 37 as dividend. Okay. So now what we can say is 37 is equal to 5 times of 7 plus 2. That's exactly what is written here. Okay. Any number that we are dividing, the dividend equal to divisor into quotient plus remainder, that's the remainder theorem for you. Concept of negative remainders. When we divide 95 by 17, then the positive remainder is 10 and the negative remainder is minus 7. So the sum of the value of positive and negative remainder is equal to the divisor. Sum of the value of positive remainder, so remainder positive plus remainder negative, is equal to the divisor. Okay. So it is equal to 17, correct? So when you divide 95 by 17, you have positive remainder 10. So that means negative remainder, how you know that? You can just simply subtract 17 by 10 and it will be 7. Okay. and just put a negative sign here. Okay, so 7 is the negative remainder. Okay, next 37 by 4. So when you divide 37 by 4, then the remainder will be 1. Okay, or you can just simply think it like, what number, okay, what number should I add to this 10 so as to make remainder, sorry, to make the number 17. Okay, so here we have positive remainder 1, because when you divide 37 by 4, okay, what you have? Remainder 1. This is your remainder, correct? So what should be added to this 4 so that remainder is 1? So it is minus 3. Okay. This is the sum of positive and negative remainder is equal to 1 plus 3 equal to 4. In this case here, we are neglecting the sign. Okay. So next we have, if 1 plus a to the power n upon a remainder equal to 1. If a to the power upon 1 plus a, in this case, if n is even, then remainder is going to be 1. If n is odd, remainder is going to be a. Okay, let us see an example. We have 68 to the power 131 and upon 67. So the numerator here is 68 and the denominator here is 67 and the power here is 131. So what we want to do is, you have to just remember this form, 1 upon a to the power n upon a, and this number can be written as 67 plus 1 to the power 131 upon 67. So here a is 67 and n is 131, and what we just saw, in this case the remainder will be 1. So for this example, the remainder is going to be 1. Okay. Next we have 67 to the power 131 upon 68. So the second form will be used here. Okay, since the power is odd, what we had, if the power is odd, the remainder is going to be a. So here, what do we have? 67 to the power 131 upon 68. Now identify. It is a to the power n upon 1 plus a. So numerator is 68, denominator is, okay, sorry. So numerator is 67, denominator is 68. So you can write it as 67 to the power 131 upon 67 plus 1, which is exactly the form which we wanted to see. So here n is, so here the power is odd, 131. So the final answer is going to be based on the result what we saw. Here denominator greater than numerator by 1, hence we check the value of power. Since the power is odd, so the numerator, the value of power is 131, a is the odd number, hence the remainder is 67. Okay, so what you have to do here is just keep in mind this theorem. If a form is given to you like this, 1 plus a to the power n upon a, in that case remainder is going to be 1. If a to the power n upon 1 plus a is given to you, in that case, if it is even, then remainder will be 1, and if it is odd, the remainder is going to be a only. Okay, so let's move ahead. Let's see Euler's theorem. So we have a to the power fn upon capital N, and in this case the remainder is 1. So what is a, what is fn, what is capital N? Let us see. Fn is nothing but a torsion function. So what is a torsion function? Wait, we will see each and everything in detail. So n is a natural number, okay, and a and n are co-prime numbers. Okay, maybe you are not able to just completely grasp it at the moment, this theorem, but once we see an example, then it will be clear to you. Okay, so how do you find the torsion function, that f to fn? So suppose we are given a number n, a natural number n. So what you have to do is just find the prime factorization and write it as a power of primes, p1 to the power n1, p to the power n2, p3 to the power n3, and so on. Fn will be equal to, this is the formula which you have to remember. Okay, so Fn is going to be n into 1 minus 1 upon P1 into 1 minus 1 upon P2 and so on till 1 minus 1 upon Pn. So, okay, so if n is 9, so it can be written as 3 square. So Fn will be equal to 9 into 1 minus 1 upon 3 and Fn will be 6. Okay, or if n is prime, in that case you can directly compute the value of Fn, and that is going to be n minus 1. So if you have value of n as 5, in that case the f5 is going to be 4. Okay, factors and multiples. A number which divides a given number exactly is called a factor or a divisor. Okay, of that given number, and the given number is called a multiple of that number. Let me just repeat myself with the help of an example. So if I say 24, so 24 is completely divided by 2. So we can say that 2 is a factor of 24, and we can say that 24 is a given number, and the given number is also called a multiple of that number. So 24 is exactly divisible by these numbers. So 1, 2, 3, 4, 6, 8, 24 are called the factors of 24, and 24 is called as a multiple of these factors. Okay, is that clear to you? Let us move ahead. 1 and itself are called improper factors of the given number, while rest of all factors are called proper factors. Prime factorization. So just now I used the term prime factorization when we were trying to find the torsion function. So if a natural number is expressed as a product of prime numbers, then the factorization of numbers is called its prime factorization. For example, 72 is written as 2 to the power 3 into 3 square, where 2 and 3 are prime numbers, and this is a prime factorization for 72. Okay, so where this prime factorization is helpful? So this prime factorization is helpful in finding lot of manner, in lot of ways. First of all, if any number n is given to you and it is written as this in this form after prime factorization, where a, b, c are prime factors of n, then number of factors that n is going to have, that means number of divisors. Okay, just recall this stuff that we wrote here, factors or divisors, that how many numbers divide that given number. Okay, so how do you know that? One way is to just check all the numbers, but how do you do that quickly? So you can just take the powers, add 1 to them and multiply. So x plus 1, y plus 1 and z plus 1, that will be the answer for you. Okay, so the product of factors, what is going to be the product of factors? It will be n to the power number of factors divided by 2. Okay, next let us see an example. So you have 2160. So what we have to do is first of all write the prime factorization for it. So it will be 2 to the power 4, 3 to the power 3, 5 to the power 1. So number of factors it will have is 4 plus 1, 3 plus 1, 1 plus 1. Just multiply this number and you will get number of factors, that is 40. And product of factors will be 2 to the power 60 to the power 40 upon 2. Okay, so next we have is series. Some series follow the definite pattern we say that there is a progression. These progressions are called arithmetic progression, geometric progression, and harmonic progressions. We are going to see that in more detail. Okay, so what is the sum of factors? So what is arithmetic progression? So when the difference from any succeeding term to its preceding term remains constant. For example, 1, 3, 5, 7, 9. So if you have a look over these numbers, 1 and 3, we added 2 here. 3 to 5, there is a difference of 2. 5 to 7, there is a difference of 2. And 7 to 9, there is a difference of 2. So in a series, in a sequence, when the numbers appearing have a constant difference, okay, in that case we say that is series or the sequence is in arithmetic progression. The first term is denoted by a and the difference is denoted by d. So here a will be 1 according to this example and the difference here is 2. Okay, so how do you know the nth term of an series? If I just for example, if this series given to you 1 3 5 7 9, and then if I ask what is going to be 100th term of this series, so how do you find it? So for that you have a very simple formula, that is al equal to a plus n minus 1 d. So you have the value of a, you have the value of d, just put n here. For example, if you want the 70th term of that sequence, put n equal to 70 and you will know the 70th term of that sequence in fraction of seconds. Okay, so now for this series 1357, if I want to find the 20th term, just put a plus n minus 1 d. So a is 1, d is 2, so n will be 20. So just solve it and you will get 39. So 39 is the 20th term for this series. Okay, so if I want to find the sum of these numbers, so that is going to be n upon 2, 2a plus n minus 1 d, or I can say n upon 2 a plus l as well. Okay, so that was arithmetic progression for you. So next is geometric progression. So in geometric progression, each successive term is multiplied by a fixed number. In the last type of series, the numbers were added. Now, what we are doing is we are multiplying the numbers to the series. So here, 2 is multiplied to 1, we got 2. We multiplied 2 here, we got 4. We multiplied 2 here, we got 8. We multiplied 2 here, we got 16. So it goes on and on till infinity. So the first term we denote by a and it is 1, and the common ratio. Last time we had common difference which is denoted by d. Here we have common ratio that is denoted by r. So what is r? A very simple way to find is just divide the numbers 2 by 1, 4 by 2, 8 by 4, and you will clearly able to see that we have a common ratio that is 2. Okay, how do you know nth term? So to find the nth term of a given geometric progression, the formula is a into r to the power n minus 1. Okay, so if you have the series like 1 2 3 4 1 2 4 8 16 32 and so on, so if I want to know, so 30th term, so a is 1 here, the common ratio is 2 here. So according to that formula, a into r to the power n minus 1, the result is going to be 2 to the power 29. So find the sum of this series. The formula is a into 1 minus r to the power n upon 1 minus r when r is less than 0, less than 1. And it will be a into r to the power n minus 1 upon r minus 1 when r is greater than 1. So if I want to find the sum of 20 terms of the previous series, this series, so r is greater than 1 here because it is 2. So we will be using this second formula here. Okay, so what is an harmonic progression? The harmonic progression is defined as a sequence of real numbers which is determined by taking reciprocals of arithmetic progression that does not contain 0. So 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6 is an example here. Reverse all the numbers given in series, we get the harmonic series. So 1, 2, 3, 5, 6, since difference is equal, this series is in AP. Hence, the earlier series, this 1, 1 upon 2, 1 upon 3, 1 upon 4, this is in HP. So what is the mean? The arithmetic mean, geometric mean, and harmonic mean are three different measures of central tendency used in statistics and the mathematics to summarize and describe data in various ways. Each of these means has its own unique properties and use cases. So, how do you find arithmetic mean, average? So, that is a very simple formula that just take the sum and divide it by n number of values. So, you will have your arithmetic mean. Arithmetic mean gives equal weight to each data point and is sensitive to outliers in the data. It's used for summarizing data when you want to find typical or representative values. Geometric mean. A geometric mean is used when dealing with quantities that are multiplicative in nature, such as growth rates, ratios, or exponential data. It is calculated by taking the nth root of product of n values. So here is the formula. You have n different data points given to you. You have to just take the product and write 1 upon n in the power of that product. Okay. What is the harmonic mean? Harmonic mean is used when dealing with rates, speed, or frequencies. It is calculated by taking reciprocal of arithmetic mean of reciprocals of set of values. So this is the formula for harmonic mean. 1 upon x1 plus 1 upon x2 plus just take the sum and put it below n. Okay. So there are some properties of arithmetic mean, geometric mean, harmonic mean that we must see. If n in a, g, and h are arithmetic, geometric, harmonic mean of two positive number a and b, okay. So what do we say? That a is greater than g greater than h. So we are giving a relation between arithmetic mean, geometric mean, and harmonic mean. Arithmetic mean will be greater than geometric mean and harmonic mean, and geometric mean is greater than harmonic mean. And another relation we have here is g square equal to ah. Okay, when a, g, h are in GP. This only holds when arithmetic, geometric mean, and harmonic mean are in GP. That means you first have two data points A and B. Okay, you calculated A, you calculated G, you calculated H, and now A, G, H are in itself in GP. In that case, this relation holds. Okay, so now we have a to the power n plus 1, b to the power n plus 1, a to the power n plus b to the power n. So a and b are the same numbers that we just started discussing with, and this fraction is equal to a if n is 0. This fraction is equal to g if n is minus 1 by 2, and this fraction is equal to h if n is minus 1. You have to just memorize this result, and whenever we will have any example related to this, we will see. Okay, so that would be all for now in the first lecture, and see you in the lecture number 2. Thank you very much, and I hope you understood the concept very well, and I would request you to just quickly go through all the slides and recall, just keep in mind the statements, the results, the tricks, so that you can solve the question as fast as possible. Thank you very much.